In the third part of this three-part lecture, I want to return to the idea of authenticity of origin and messages, because the most common form of message that we transfer today is emails. Email is an almost ubiquitous form of messaging, although there are, of course, instant messaging protocols and others, but email is kind of the lowest common denominator. So, to understand how emails can be signed, and also we'll later on look at encrypted, you need to understand how email works, first of all. Now, email goes back to the very, very early days of the internet, or even before the internet. It was designed originally to operate over 7-bit, not 8-bit, but 7-bit links. You couldn't transfer entire bytes. You would have to transfer 7-bit ASCII or ANSI type characters. So it was great for text only. And originally, email systems were very balkanized. There were lots of different networks like BitNet and Alternet. And there were systems that were based not on actually using a permanently connected network, but instead on using dial-up connections. For Unix systems, for example, email was actually transferred by a program called UUCP, which is Unix to Unix copy. And Unix boxes would batch up emails during the day, and then at night, when long-distance phone charges were the lowest, then dial up and use UUCP to transfer batches of compressed emails, but compressed only to transfer over 7-bit links. There was a similar system for bulletin boards based on CP/M and MS-DOS, like FidoNet. I was actually involved in the early days with FidoNet, where I was node 3:3/1.3. And it was a similar system that would batch up emails and then dial up. Especially down here in Australia, we would do the long-distance transfers to and from the US in the dead of the night at the lowest possible cost. So back then, when internet email first appeared, it was designed to be interoperable with these other systems. And if you look at, for example, the most common or oldest mail server for Unix and Linux out there, a thing called SendMail, you'll find that a lot of the complexity of SendMail is to be able to rewrite addresses and provide a gateway between internet email and systems like UUCP and Alternet and BitNet. Now, internet email itself is defined by some internet RFC documents, requests for comments, particularly RFC 2821, which defines the Simple Mail Transfer Protocol, or SMTP, which is the protocol that's used, and then RFC 2822, which is the message format. And the format of an internet email is actually just text. It's multiple lines of text. There's a header, which has got fields like from, to, subject, date, colon, etc., with the appropriate arguments. Then there's carriage return line feed to produce a blank line, and then comes the email body as opposed to the header. And that's what RFC 2822 defines. Those of you who've studied web programming, for example, will realize that the HTTP protocol structures messages similarly. There's an HTTP header with multiple fields, one per line, then CRLF, carriage return line feed, a blank line, and then comes the body, which contains the actual HTML of a web page. It's a bit complicated now by new versions of HTTP, which are binary only, but that's how the classic HTTP version 1.1, for example, works. So with email, here's how it's designed to work. You would write your email sitting at a computer running a mail program. Now, a lot of students these days are used to using services like Microsoft, what used to be called Hotmail, and is now called Office 365, Outlook, or whatever, on a web server. So you normally run a web browser, and then as you compose your email, it actually is constructed on a server somewhere in the cloud. But that's not the way that things are really designed to work historically, and as you'll see, there are good reasons why you might not want to use it that way. Instead, the user uses an email program, and there are a whole bunch of these things out there. The original Microsoft Outlook, as part of Microsoft Office, for example, is such an email program, or a mail user agent, as the literature calls it. I personally use Mozilla Thunderbird, for example, along with various extensions, which we're going to talk about a little later. And there are lots of other versions as well, lots of other programs. People used to have their own preferences. So you would actually fill in a form with the destination email address, reply to address if it was different from your own email address by default, the subject line, and then in the main pane of the application window, you would type up and edit your text. Once you'd done that, you would click the send button. And at that point, the mail user agent program, Outlook, Thunderbird, whatever, would actually open an SMTP connection from the mail user agent to your outbound mail server. The mail server is actually called an MTA, or Message Transfer Agent. And so it makes a TCP connection from the mail user agent to the outbound MTA. It takes your email and formats it according to RFC 2822, and it sends the header lines, the blank line, the body of the email, and then closes the connection. The SMTP conversation, by the way, you can actually look at, and if you're involved in security, you probably want to be able to fake one of these. It starts with a hello, HELO, and your host name, gets back a 250 OK, then mail from : your email address, recipient to : list of recipients, data, and then blank line, then comes the data. At the end of the email body, okay, it will then insert a dot on a line by itself, and that's the end of the conversation, and typically it then says bye and breaks the connection. So in the case of the outbound MTA, the mail transfer or message transfer agent, it now splits, in the case of classic SendMail, it splits your email into two files. One contains the header, one contains the body. It looks at the destination mailbox address, which will be some username at the destination company or entity or whatever. And it then uses the DNS system to find the mail exchanger, i.e. the inbound mail server for the destination mailbox. And it repeats the process. Now you have a SMTP conversation between the outbound MTA Corporation A and the inbound mail server at Corporation B. And it does the SMTP stuff, sends the RFC 2822 formatted email body, says goodbye, etc. Now that then looks at the destination mailbox address yet again, and very commonly the MTA that you've sent the email to is actually in a DMZ firewall screen subnet. It's not actually inside the company for security reasons. And so you send the email to their inbound MTA, it then examines the header lines and it forwards it on to an internal MTA, using exactly the same thing, SMTP. Now, in the early days of email, the internal mail machine would be a Unix box or whatever. You have a dumb terminal, and your mailbox actually just existed permanently on that Unix box. But these days people use Windows desktops and Macintoshes, and so your mail stays on that mail server until such time as you pick it up, okay? Because your machine isn't always connected, isn't always powered on, etc. But you come into work, you power up your PC, you log in, you start your mail client, and you fetch your email. And rather than using SMTP, which is a push protocol, it pushes email to the next destination. Now it's reached the final server, it will use a protocol like IMAP, or in the old days it was a thing called POP. IMAP is the Internet Mail or Message Access Protocol, which is a pull protocol to download the email into the destination MUA or mail program. Or POP was the post office protocol, which is much more simple and primitive and really isn't used these days. So unlike SMTP, which doesn't require authentication, it can use it, it doesn't normally require it. In the case of IMAP and POP, the user has to log into the mail server with some credentials and then download the emails and then display them and read them one by one in the mail program. As I mentioned, MUAs are actually much less common these days. Yahoo Mail, Hotmail, Microsoft Outlook, Gmail, etc., have made browser-based email popular, especially if you're doing things like traveling, for example, or you're using things like Chromebooks, or you're using lab computers in a university environment. You can just fire up a browser and connect to the mail web server. And the web server provides the MUA functionality. So in this case, at Company A, the sender uses their web browser to connect to the webmail server. And then once they've formatted the email in a window, okay, it then, when you click send, runs some PHP code or some JavaScript code, Node.js or whatever. In the case of things like Gmail, it actually uses a spun up container to do this. And it then does that outbound SMTP conversation to the outbound mail server, to the destination's inbound mail server, through the firewall to the internal mail server, where typically that also has a web server. And the recipient then is reading their emails and it appears in their Gmail inbox or whatever. So you may not be aware of the use of MUAs, but they actually are still very important. And they have certain advantages. They allow you to work offline. I mean, I can be sitting on a flight with no internet access, though that's actually becoming more common these days. And I can work offline. I can compose emails. They stay in the kind of outbound queue. And whenever I get to my destination or I check into the hotel, connect to the internet, and a whole batch of emails gets sent. Another important point is that I have multiple email accounts. I have email accounts for 2 different companies at least. I have the Macquarie University account, etc. And I want them all in one interface so I can work in one program, one window, etc. And so Thunderbird and Outlook allow me to create multiple accounts for multiple different identities that I've got, and it will pull down the email from all those sources. It can integrate with other applications. Okay, I can actually have calendaring and stuff built into the MUA program as well. And I can do a lot of very interesting things in terms of scripting on emails inside a mail client. But most importantly, from our perspective, there's the ability to perform cryptographic functions on my computer. If I'm composing an email on somebody else's web server, they own it, they operate it. How can I sign that email? Because to sign it, I have to use some code which will perform calculations involving the message body of the email. Clearly, you can't actually encrypt the header. It's got to be processed by various servers, so they want to be able to decrypt it, so it must be plain text. But the body of the email gets signed or encrypted using, in the case of signing, my private key. Now, if I put my private key on someone else's web server, it's not private anymore, right? And so I've just compromised my own security. If I have to upload my private key, I've got a problem. Now, in practice, HTML and JavaScript with HTML version 5 and AJAX, use of JSON, etc., it actually is now a bit easier to have JavaScript code running in a browser and have that JavaScript code able to use your private key in your browser to sign or even encrypt the email body before sending it up to the web server to be assembled into an email and sent. So browsers aren't necessarily a barrier, but it still is pretty tricky. Google with G Suite, for example, allow you to sign and encrypt emails, as we'll see, but you have to have the enterprise version of their G Suite product. You have to be a paying customer. You can't do it with conventional Gmail or even the cheap versions of G Suite. So typical MUAs are things like Microsoft Outlook, which used to be part of Microsoft Office. It's no longer provided. You have to actually buy it. But Mozilla Thunderbird is free, open source, well supported with lots of extensions for a variety of applications. And so when we come to actually do this in practice, and it's a really, really useful thing to do, that will be the basis of our workshop lab exercises. And there are many other MUAs running on the Macintosh and running on Unix, etc. Although Thunderbird tends to be pretty universal these days as an open source cross-platform platform. And in fact, things like the Thunderbird extensions are very often written in JavaScript, and so you know that you can install the extensions on a Macintosh or on Linux or on Windows, and the extensions will work everywhere, which is something we count on. Now, a very important extension to email, and it's got some serious implications, for security is MIME, Multi-Purpose Internet Mail Extensions. The idea that email should consist of just 7-bit ASCII or ANSI text doesn't fly these days. People want to embed graphics for company logos. They want to use various different fonts. They want to do things like attaching huge spreadsheets and PowerPoint presentations onto their emails and send them. But you can't send a binary spreadsheet on a 7-bit ASCII link. So what you have to do is take your binary and turn it into 7-bit ANSI text by using an encoding scheme like base64 or UU encoding, which is what the UUCP program used to do. And that actually turns binary into text. The problem is it also bloats it very considerably at the same time, which is why email programs these days try to caution you against big attachments. If you attach, for example, a 10 megabyte, let's say, PowerPoint file, it'll bloat out to become 18 or 20 megabytes of an email. Now, apart from just that, I describe multi-purpose internet mail extensions, MIME, as being the spawn of Satan. It's the worst invention in all of computing technology. And the reason is the problems it causes for security, let alone the fact that people attach these huge PowerPoints and Excel spreadsheets. I do tech support for my wife's company, and she sends large documents through to her clients. And what happens is you wind up with a 100 megabyte email, and the destination inbound mail server says, "Whoa, that's too large, I'm not accepting that," and it bounces back. Then she gets on my case and says, "Why can't it send my email? Go and fix this." And I say, "Not my problem." In fact, now I forced her to use Gmail and G Suite, so that becomes their problem. But the worst thing about it is that it makes possible rich formatting in emails, especially HTML formatting. And that means that we can actually have links, which are HTML href equals, and then some URL, close angle brace, then a different plausible URL, angle brace /a. And that means the URL looks like one thing but takes you somewhere else. That's what phishing depends on. If it wasn't for MIME, we wouldn't have phishing attacks. And so it really is a major pain. It really is. A lot of security work revolves around various kinds of spam, unsolicited commercial email, malmail, malware delivery via email, etc. So, options for signing email. There are two basic schemes, and we're going to look at one of them in next week's workshop and one the following week. First of all, there's PGP, and it's kind of compatible open source documented protocol OpenPGP and the open source implementation GnuPG. PGP itself these days is actually a corporation, PGP International, so you would pay to use their software. But the GNU Privacy Guard, or GPG, is an open source version of PGP, and that's the one that works best across things like Windows and Macintosh. There's also GPG built into virtually all Linux distributions. We can count on it being there. As I mentioned, it was developed by a guy called Philip Zimmermann back in the early 1990s. They started development back in the 80s, in fact in the days of 8-bit machines and running it on Z80s. But they finally completed the project properly in the early 1990s, and the motivation was primarily political rather than financial, which is why it's open source originally. The idea was to make cryptography available to everyone so they can be free of government snooping into their email contents, etc. And this actually is where IDEA came from, which we talked about in the second week, the International Data Encryption Algorithm, which was developed and used in PGP version 2 or thereabouts. Now, SMIME, Secure Multi-Purpose Internet Mail Extensions, was developed by RSA Inc. and is an alternative that's quite widely deployed in corporate environments. Security professionals tend to prefer PGP. Linux people prefer PGP. The corporate world tends to prefer SMIME, and it's implemented and built in as standard in Microsoft Outlook and as standard in Thunderbird, whereas PGP has to be added by some kind of extension or add-in. So to configure Thunderbird, I'm going to get you in the workshop to actually set up Thunderbird on your laptop. Now, to install Thunderbird, I'll give you the link so you can download it from. You download Thunderbird, and on Windows, you just simply, just double click on the installer and it installs and off you go. On Linux, very often it's a matter of using your Linux package manager to install it. There's also a package for Macintoshes as well. And when you start to run it, the first thing it will do is get a little wizard. It asks you what your email address is. And my experience has been that it works out that Macquarie University students use Gmail. And it's got the configuration information for Gmail in its configuration database. And so it largely is automatic. But I will provide you with manual configuration instructions should you need it. What I recommend that you do, though, is this. Once you've got a connection to the Macquarie Gmail account, you'll have various folders in your Gmail account. That's what IMAP lets you do. And you probably don't want all of that stuff downloaded onto your laptop necessarily. So what you can do is right-click on the mail folders that aren't that important to you and choose Properties. Then there are various tabs in the Property dialog. You choose Synchronization and turn off. Select this folder for offline use. If you don't do that, what it will do is go through all the various folders and download all of your emails into it. And that will take some time. And if you've got a lot of stuff in your email account, it'll also take a lot of space on your laptop. But it is useful. If you travel, right, it means you can have folders containing the stuff that you're working with on your laptop and use them offline. Or if you have other reasons for using it offline, that can be very, very useful as well. Now, to add PGP support to Thunderbird, if you're working in the lab, and I actually advise against it, and of course, at the moment, we're working remotely, and so you can't go into the labs, but on your own laptop, you should install GPG for Win, or check that your Macintosh already has GPG installed. Right? Now, GPG for Win, I'll give you a download link for. That installs the GPG programs. Linux always has GPG installed, and you can use it from the command line straight away. But then once you've got Thunderbird up and running and you're able to send and receive conventional email, then you should add an add-on or plugin for Thunderbird called Enigmail. Now, Enigmail, as the name suggests, Enigma machine, Enigmail, etc., actually provides additional menu options and buttons and fields to allow you to use PGP for both signing and encrypting email. And if you go to Tools, Add-ons, Get Add-ons, and then search in there for Enigmail, and usually it's very near the top because a lot of people install it, you can then have it automatically download and install Enigmail for you, and then you just restart Thunderbird and it's there. When you install GPG for Win, or you set GPG up, typically GPG for Win will walk you through the creation of a public-private key pair. Now, my recommendation is that you create a public-private key pair that either never expires or that is at least long enough to survive through your university times. This particular GPG key pair will be for your username at students.mq.edu.au account. So as long as you're planning on being a student in Macquarie for the next 2, 3, 4 years, whatever, make sure that the expiry date of your key is that far in the future or just doesn't expire at all. Smart people, right, will actually create a non-expiring key, and then they'll create other keys that are shorter lifetime, and they'll use their non-expiring key to sign the keys that they intend to use for a 2-year, 3-year period or whatever. Now, GPG itself can support all the various popular algorithms that we've talked about earlier in this course. It can use AES, it can use Cas5, Camellia, the Japanese cipher, Triple Des, Blowfish, Twofish, etc., and probably a lot more by now. For public key, they can do encryption using LGMAL and RSA. It can do RIPE MD160, Tiger, MD5, SHA-1, SHA-2, and probably SHA-3 by now. For digital signing, it can use DSA, RSA, and I haven't checked, but probably it can do EC DSA as well. Now, We've previously discussed in the lecture on hashing techniques for signing using secret key crypto. And the techniques that I've mentioned, which actually generate a message authentication code, not a true signature, right, is to prepend a shared secret in front of the message, and then calculate a hash over both the secret and the message, and then just send the message. And that's the technique that, for example, chat uses for authentication of PGP sessions. It's vulnerable to length extension attacks, however, unless you're clever in what you do. An HMAC is a more complex construction which requires hashing twice. Right? And we discussed this in the week 3 lecture. Any hash function can be used. They used to use MD5, but SHA-1, SHA-2, SHA-2 especially, has now replaced it. But remember, it can still be repudiated. Signing with public key crypto, the sender computes a digest over the message. Then the digest is encrypted with the sender's private key. And that is actually sent along with the email as an appendix onto it. You'll see how it's done in the next slide. Now, of course, the recipient does the same digest calculation, then decrypts the signature with the sender's public key. If they match, the message wasn't corrupted. The message was sent by the holder of the private key that matches the public key. And the sender, if they hold that private key, which they must do, can't deny they sent it. Right? Unless they want to disclaim that private key completely and say, oh no, you can't believe anything that was signed with that key, I don't have it. It was compromised. Now the $64,000 question, as I mentioned in a previous part of this lecture, is how do I know that the public key that you claim is yours really is yours? And the way we solve that in PGP is by signing each other's keys. Now, some of you will have already received emails from me because we've been corresponding about problems, and I typically would sign the email I return as plain text with the inline signature immediately following the text. So typically you'll see this in emails that you've received from me. It says begin PGP signed message, then comes the actual text of the message. Then there's a bit at the bottom that says begin PGP signature version 2.2, and then comes a great big block of text, which is the PGP signature, which was binary but turned into some text using base 64 encoding, end PGP signature. The nice thing about this is the entire email is ASCII or ANSI text, and it won't get interfered with by various programs that manipulate the text inside an email. There are some mail servers that will mess with the body of an email. Yahoo in particular does this a lot when you use Yahoo mailing lists. Alternatively, you can sign emails with PGP using SMIME, in which case you won't see the signature. It's a separate part of a MIME encoded multi-part email. And that's used when you have, for example, things like rich text, etc., in the email and attachments, etc. anyway. Now, the question then becomes, where do you get the public keys from? Now, you can actually automatically append the public key. I'm going to make you do some harder work, though. Okay? Rather than appending or attaching the key onto the email, I'm going to make you actually publish your public key on a key server. You recall that in earlier lectures about digital signatures, I said that you retrieve the sender's public key from a directory or a registry or white pages or whatever. And so for PGP, there are actually directory servers run by MIT and by PGP Inc., etc. And in fact, the Enigma plugin lets you right-click and automatically download the key by going to the right key server. The big problem usually is finding the right one of several different key servers, and it may take you several attempts to find someone's public key that way. So in summary, throughout this large three-part lecture, we've looked at, first of all, authentication techniques for logging onto systems by means of something you know, something you have, something you are. And for things like passphrases, we looked at how they get stored, we looked at attacks against them. We also moved on to look at authentication protocols in distributed systems for both authentication and key exchange. And we discussed some of the attacks against those protocols, but clearly there are lots of them. And we also discussed in a bit more depth at least one real symmetric key or secret key authentication protocol in use today, Kerberos, which, as I mentioned, is used in Unix-based systems and also is the basis of Microsoft Windows Active Directory. And we talked a bit about signing, both in theory in an early lecture and in practice in the context of PGP emails. So that's the end of this lecture. The remaining slides in this actually are just references of one kind or another. Our next lecture will build further on this by looking at network and telecommunications security, putting it all together into hybrid crypto systems that are used on the web and for logon authentication, terminal emulation, and other various different applications like Wi-Fi, etc. So that will come in the next week's lecture. You'll actually have a workshop following on from this in the next week, which will deal with the practicalities of signing emails using PGP. And a subsequent exercise will get you to actually encrypt emails and do some work with TLS, etc.